Hello everyone, my name is Viraj and today we'll be looking at the ninth problem from the CP-31 sheet by TLE Eliminators under the 1000 rated questions. Let's go. So moved on to my sheet over here, ticked off 1000 and this is my ninth problem, minimum LCM. Let's read this. Very simple and short problem. You are given an integer n. Your task is to find two positive greater than 0 integers a and b such that a plus b is equal to n and the least common multiple, that is LCM, of a and b is the minimum among all possible values of a and b. If there are multiple answers, you can print any. Alright, so let us quickly generalize this problem. They are saying that they will give you a single variable that is called n, and they are expecting you to in return print two variables or two numbers rather, a and b, such that condition 1, a plus b is equal to n, and condition 2 is that LCM of a comma b, let's say the LCM of a comma b is L, then this L value is the lowest possible. And the third condition is a is greater than 0 and b is also greater than 0. So if you are able to find two such numbers a and b which satisfy all these three conditions, and to be very specific, the most important being second condition, their LCM is the lowest possible, then a and b can be printed and they are a correct answer. Let us take a quick example. Let us take the second example. For example, n is given 9 over here. So I've actually written all the values for you. What I've done is I have taken the possibility of a and b. So a can be 1, b can be 8, 1 plus 8, it's 9. Similarly, you can make a increasing, so a goes let's say 2, then b will automatically come down, it is 7, so 2 and 7, that also makes up 9, 3 and 6, 4 and 5, then 5 and 4, 6 and 3, 7 and 2, 8 and 1. So I've listed all the possible pairs of a and b that you can make for, again, creating n equals to 9. And then I have written their LCMs next to it. So L is 8, L is 14 in this case, L is 6 in this case, L is 20, L is again 20, 6, 14 and 8. This is basically the LCM of these two values. Okay, now it's fairly obvious to see that I have basically ticked off two conditions for me as of now. I'm talking about all the pairs that have the sum as 9. So this is ticked off and I've already ticked off the third condition because I'm only talking positive values. Let's take the pair which has the lowest LCM, L. Let's see, 8, 14, 6, 20. What is best? 6. So can you take the answer as 3 and 6? Yes, it can be said. So I can say A becomes 3 and B becomes 6. And this is the right answer. If you go back and see, yes, 3 and 6 was given the answer. Alright, so I hope the problem has now become clear. Pause the video, run your idea through all the other cases also, and you will actually see that the output that they are saying is actually right. You will find for that pair the lowest LCM that you create. They will sum up to be n and they will be positive as explained. Alright, so let us move on to now our time complexity discussion. We are done with the question discussion and the sample cases. Now this is very fun. We have been told that one test allows me 2 seconds. So I can write this as one test giving me 2 into 10 raised to 8 operations. Now after this, inside one test, there are some test cases that is 100 order. So if I find the number of operations I can perform on an average for a test case, then I'm looking for something like 2 into 10 raised to 8 upon 10 raised to 2, which is, you can say 2 into 10 raised to 6 order. Alright, but if I look at n actually, n is given very large. N is given actually in a 10 power 9 order. Now, if n is given so large, can you actually create a linear solution? I don't think so. You cannot create linear solution. That means you will have to go a little down. Now, from here on, by experience, either we can create something like square root n solution. Square root n will just fit the 10 raised to 6 boundary also. If you go even best, that's like log base 2n solution, or you go in a constant time. So solutions like this is what we are actually looking for. Either a square root, that's like an upper bound, and then you go further down like log or constant solution, but you cannot do anything in linear time, and of course you cannot do anything above that. So anything in square or cubic order, that is automatically out of picture. And this is expected time complexity discussion, which is very, very fruitful because this tells me I'm not looking for any brute based solution. We actually understand what do you mean by brute based solution in this question, but then I hope this part should help. Now from here on, pause the video and I think you can try this problem once because this is a very interesting problem. If not, let's begin with the idea. I've actually copy pasted the same case that we discussed in the sample and let's try to derive some observations from here. Listen to each observation carefully. First things first, I said that no brute idea. Let's actually see what do I mean by that. A brute idea would have been very simple. You could have actually run some sort of a solution that is like a for loop, where you could have taken the value of A every time as 1 to, let's say, 8 in this case. And then similarly, B would have been simply n minus A. So B would have been 8, 7, and so on. Every time you could have founded inside that loop the LCM of A comma B and minimized this with some variable. This is very simple. I hope this is clear. This solution would have been O of n order. Why? Because you would be running a loop from 1 to 8 in this case. That roughly means 1 to n minus 1. That is n order. So I hope the brute solution is making sense. But the problem is this will not work. This is a linear solution. So now if this doesn't work, how do we improvise a brute solution? First thing is, maybe we can talk about limiting our search space. We know that we are actually running a loop from 1 to 8 over here. But is that needed? This is where first idea comes into picture. See very carefully, there is actually a line of symmetry, which actually makes sense. This line of symmetry is because after a point of time, you are basically reversing A and B. See, A and B right now are 4, 5. Then it becomes 5, 4. It has 3, 6 over here. This becomes 6, 3. Then 2, 7. This is 7, 2. 1, 8. This is 8, 1. And similarly, the LCMs 20, 20, 6, 6, 14, 14, 8, 8, they get also repeated in a symmetrical format. That is why what I can write from here is a general case that if I am looking for a brute solution, or had I been going for a brute solution, I don't want to actually iterate on all the possibilities. Rather, just half of the section is fine with me. Or what I can say is I would find the answer in this half of the section, because after the symmetrical part, the LCMs basically repeat. Okay, symmetrical half. Symmetrical half. Now, this brute solution will decrease from n to n by 2. Why? Because now you would be iterating only to half of the values. But is this still fast enough? I don't think it's fast enough, right? N by 2 is also roughly in n order, so this is not also going to work. But from here on, I have actually derived one important idea. That is, I can put a general limit on A and B. First of all, I can say that if I'm talking about only the symmetrical upper half, because down half is something I don't want to check. So I know A is always less than B. See this over here. If you observe A, it is always less than its counter, that is B, B, B. Because as soon as A crosses or goes greater than B, you jump to the next half. So you know that A is always less than equal to B if you're in the first symmetrical half, by the way, where you will find an answer. So it's fine. Third idea, which I can see very clearly, is B is less than equal to n minus 1. See over here, B started with 5, then maximum B goes to n minus 1. Because if you take n minus 1 as B, then 1 will be A. So B cannot cross n minus 1. That means it is always less than equal to n minus 1. Now the fourth idea is, I've actually set a small upper bound on B, right? I'm saying it's not greater than n minus 1. I also have a lower bound. If A is less than equal to B, so I know that A plus B is equal to n. Now in worst case, if A turns out to be equal to B, that means this is like B plus B is equal to n. That means B is equal to n by 2. And from here on, if I say A is only lesser, because this is the best case for A, then I know that B will only increase from here on. That means B is greater than n by 2 also. Take 2 minutes to yourself and look at all these 4 ideas once more. I hope all of this should make sense. Now, you will say, why are these points very useful? This is where the main logic starts with. Listen to this very carefully. Now, up till this point, all that we have established are some rudimentary ideas on the limits. And we have said that the brute solution is not going to work for us. Now, this question is actually talking about LCMs. If it talks about LCMs, it's only natural that factors also come into picture. This is again by experience. If this did not strike you, no worries there. This is actually a very tricky problem. So from here on, my next idea can be that if I have to even further my search space, can I think in factors? Meaning, I'll insert one more idea. My question is, does it help to observe something if A is a factor of B? Let's see. If A is a factor of B, that means B mod A is equal to 0. And B by A is a integer. So I'll call that integer, let's say F, and F is an integer. It's like a factor basically, so it's an integer. Now let's see what is the LCM of A and B now? You must have seen this ladder method in elementary mathematics, right? A and B over here, and then start processing these numbers to find the LCM. So first I can write A by A will be 1, and A by B will be that F number, right? It is an integer. Next time I can write F, this becomes 1 and this becomes 1. I can find the LCM, and LCM in this trick is basically multiplying all the numbers on the left ladder that have been created. So A into F is actually the LCM of A comma B. Now A into F is what exactly? See, B by A was F. If you take A that side, A into F is B. That means B is equal to LCM of A comma B. So I have idea number 5 from now. If A turns out to be a factor of B, then idea 5 is that LCM of A comma B will be equal to B. Okay. Now, because we asked this question, it's very obvious to ask the counter question also. What if it's not a factor of B? What does happen then? So other half is if B mod A is not equal to 0. Let's find the LCM once more. Okay, same ladder method. You have A over here, you have B over here. So I'll place A right now. So this becomes 1, and this still remains B because B is not divisible by A anymore, right? And then I will have to place B over here. So this is 1 and 1. Now, if I find the LCM of A and B, that basically turns out to be A into B in this case. Okay, A into B. Now, in the previous case, my LCM was B when A was a factor of B. Right now, my LCM is A into B. If I can try to find a very lower bound on A into B, I know that I can keep A equals to 2. Because if I keep A equals to 1, then that is automatically this first case that I was saying, that if A is 1, then 1 of course divides B, so 1 is a factor of B. I'm taking A is not a factor of B, so A needs to be a just larger number than 1, that is 2. In this case, you can say that if I'm talking about the very lowest scenario, then LCM of A and B has to be greater than equal to 2B at least. This is when A mod B is not equal to 0. So this is idea number 6, that in this case, when A doesn't divide B, LCM of A comma B is greater than equal to 2B. Now this story is done. Let us see where does all this help us in. See, the second point was we want the least LCM. Now, if I talk about A not being a factor of B, I'm automatically saying that the LCM is at least 2B. But if A is a factor of B, then I'm saying that the LCM is exactly B. Now, which is better of these two cases? Do I want A to be a factor of B or not? Yes, I do want. Because A being a factor of B makes my LCM exactly B, which is definitely lesser than its counter case, where LCM crosses even 2 into B. So from here, I've actually deduced a very important point, that on top of these conditions, I would also prefer that B mod A is equal to 0. I hope all of this is clear. Now, one more thing. What is n exactly? N is A plus B. Let's take n mod A both sides. N mod A this side also. A plus B mod A this side also. Now, A plus B mod A is basically writing A mod A plus B mod A plus A whole mod A. Okay, which is equivalent to writing A mod A is 0. B mod A is also 0 because B is divisible by A. This is plus A mod A, which is again 0. For all those of you who did not identify this, this is actually modulo addition property. Now, if I get the result as 0 over here, that means n mod A is equal to 0. That means if A divides B, A also divides n. So now idea number 6, which is actually the most important idea, n mod A should also be equal to 0. Now this is where our story has changed from a brute to a fairly faster solution, because initially I was talking about searching all the values in the first half, but rather in the first half also I'm only looking to search in values which are factors of n. If I get factors of n, then I know I'm basically making sure all of those values can be treated as A. If A is found, then counter B can automatically be found, n minus A is B automatically, and then automatically I know that A and B can be the right pairs. And finding factors is going to be very easy because we are well aware of a very neat method called as square root method to find factors. This method, as the name suggests, actually runs in square root complexity. So that would have something like a root n complexity, and n is in 10 power 9 order. So root n will be something like 10 power 5 order, and 10 power 5 fits our 2 into 10 raised to 6 boundary. This is what we actually discussed in the expected time complexity also, that a square root n solution will work. That is why this problem is now done and dusted. I have smartly deduced that my search space is not exactly all the numbers in this upper symmetrical half. It's basically just the factors of n. From here on, I can add one more smart idea on top of this. See, as of now, we have just deduced that you are looking A to be a factor of n, and then B automatically is n minus a. Okay. But you are not sure what is the LCM of A and B over here. You will have to find that LCM and you will have to minimize it overall. That method is also fine, but that is an extra time complexity, because finding LCM is going to have a log order extra on top of this root n already, which is something I don't want, because I'm already in 10 power 5 ratios and I'm looking for a solution that is maximum 10 power 6. So this extra log factor that comes from finding the LCM will actually harm me. Can I do anything better over here so that I quickly land on that best pair? Observe one thing very important, that up till here, by all our ideas, we are saying LCM of A comma B will turn out to be B, because I know A divides B. Okay, that was fairly said. Now, what is B exactly? B is n minus A. Tell me, your target is to minimize this LCM, or indirectly minimize this B. Now, n is pretty much constant, right? This is actually given to you. This is input. So you cannot harm this. A is something you're trying to find. If you find a very large A, then n minus a larger number will automatically land with a even smaller number. If you find an even smaller number, or in this case, even smaller B, automatically you find the lowest LCM or not. You do. That means if A is a factor of n, that is definitely an idea. But on top of it, A should actually be the largest factor of n. And this is where my final idea is resolved. Now I've actually deduced one important thing more, that I'm not even looking for all factors. This is so great. I'm just looking for the largest factor of n, and that can be treated as A. If that is the largest factor, then A is done. If A is done, then B automatically is n minus that largest factor. So that's B, and I can break. I don't need to go even further. Okay, now your question would be, how do I find this largest factor? Again, by using the properties that we do in the square root method of finding factors, I can actually find this very easily. My pseudo idea is going to look like this. I can say that my answer A, that is the A I want to print, is 1. And my answer B is actually n minus 1. This is what I initialize off with, which is fine, because I know 1 and n minus 1 is definitely a starting point. It's definitely one of those answers. Now in the square root method, I can run a loop that, let's say, starts with I2, and then I into I is less than equal to n I plus plus. This is the square root method. If I feel that n mod I is equal to 0, n mod I is equal to 0, then I can say A is equal to n by I, and I can break from here. Why is this going to work? Why am I saying n by is the largest factor? This is a small prerequisite in square root method only. I'll give you a small diagram over here so that it becomes very neat. What actually happens is square root method looks something like this. Like they say their numbers are from 1, 2, 3, 4, 5, so on till square root n, so on till n minus 2, n minus 1, n. So factors exist in pairs, right? If you pick up a factor, let's say 2 from here, its counter is going to be something like n by 2, because 2 into n by 2 is those two factors which create n. If you pick up 4, then its counter is somewhere here. If you pick up 5, then counter is somewhere here. So the lowest factor that you pick from here, the counter is going to be the largest guy from here. That is why on the first location where I find I to be a factor of n, I can say n by I is the largest factor from the back. That means this becomes A, and then automatically B becomes n minus A. And this B, this A goes to answer A, this goes to answer B, and voila, you have solved the question. Now, the time complexity, by the way, now is square root of n only. There is no extra log factor of LCM check, because you have already made sure that you land up at the lowest LCM because you are finding the largest factor. All the story made up well, and I am good to go. All right. So let us do this simulation on our case n equals to 9 also, and we will see. I would have said that the answer A would have started with 1, answer of B roughly can start with 8. So this is something I would have noted. I would have ran a loop from 2 till I can say I into I is less than equal to 9 and then I plus plus. Now I is equal to 2. So 9 mod 2 is 0. No, it's not. Let's increase 3. Oh, 9 mod 3 is actually 0. So I know that A becomes 9 by 3. That is 6. B becomes 9 minus 6. That is 3. And you basically end up printing 6 and 3. Which is also right. The answer could have been 3 and 6 also. But it would also be fine to print 6 and 3 because it's symmetrical. I hope this clarifies everything. This is again a very, very fun problem on lot of number theory. So at this rating, it's not fairly obvious to understand all of this very, very quickly. Pause the video, it can be a little overwhelming, and go through the idea once more. Follow all these small steps that I showed you, and you will be able to derive them yourself, and I think you will be able to understand why all of this works. Alright, now let us look at the coding part and see how do we implement this out. So just the same thing as I showed you in pseudocode. What I'll do is I have n over here. First of all, of course, I had t, taken the input, then n is taken input. Answer is 1, answer b is n minus 1. Then we have this square root method of factor. Factor is starting with 2, less than equal to n, fact into fact, fact plus plus. If n is divisible by fact number, then answer is n by fact. Answer b is n minus answer a. Break and print them, you get the answer. What is the complexity? This is like square root of n, which means I have actually created a time complexity that is O of square root of 10 power 9 order, which is roughly 10 power 4 to 5 order. And what about space? It's constant. Now this is for every test case, which is fine because for every test case we had a 2 into 10 raised to 6 order roughly. So this is going to work. So this is all that is there in this problem. Very fun, very mathematical problem. I hope you like it. Thank you for watching.